Greetings, colleagues and friends around the world, and welcome to the inaugural GEO Knowledge Hub webinar of the webinar series. My name is Stephen Ramage, and I'm based at the Group on Earth Observations, GEO Secretariat in Geneva in Switzerland. The GEO Knowledge Hub is a cloud-based digital library or repository providing access to knowledge required to reuse applications of Earth observations. Today's schedule includes an official opening from the GEO Secretariat Director, then an intervention from the European Commission regarding the GEO Infrastructure, and then to another of my colleagues to introduce the GEO Knowledge Hub and how to become a knowledge provider. Following this introductory session, we will move to examples from the GEO Work Program, notably Geoglam for global agricultural monitoring, then the GEO Human Planet Initiative, and then the Brazilian data coup. We will have a short Q&A at the end of the sessions, but you can enter a question at any time using the Q&A facility that you should be able to see on your screen. So without much further ado, I would like to introduce Berto, the GEO Secretariat Director, to give us the opening. Over to you, Berto.
Thank you, Stephen, and good day to everyone, and many thanks for a very nice number of attendees. I see from the surnames that you come from all over the globe. It is my pleasure as GEO Secretariat Director to introduce this session where we were going to show our aims at developing the Knowledge Hub. The Knowledge Hub, as Stephen has said, is a complementary addition to the existing GEO's infrastructure. That includes the GEO's platform and other methods of working with the community. And we today will show what it can do in terms of storing the results that you produce and that you would like to share with the GEO community. So it is enormous pleasure to see you all here. A work that has been done by the Secretariat with support from Brazil INPE and with support from the GIDTT, which is our Infrastructure Development Task Force, where one of the co-leads is here, Stefano Nativi from the European Commission. So thank you very, very much for the support you've given. And I'll hand over back to Stephen and to wish you all a very good discussion in these hours to come. Thank you so much.
Thank you very much, Berto. So now we're going to move to Jean Dessart from the European Commission and who's also part of EuroGeo.
Thank you, Stephen. Good morning, everybody. This will be my pleasure to share with you in a couple of seconds or minutes a pre-recorded video of my presentation. The overall idea is to show that the Knowledge Hub is a very important component that I'm very pleased to support and to make sure that it is well understood by the community and that it integrates very well in the rest of the GEO's infrastructure. So this presentation is done together with my colleague Stefano Nativi from the Joint Research Center. And Stephen, please go ahead.
Merci, Jean.
Good morning. Let me take the opportunity to present together with my colleague Stefano Nativi on behalf of the European Commission just a few introductory words on the place of the GEO Knowledge Hub within the GEO's infrastructure. We would like really to move towards a new GEO's infrastructure, and this effort has been taken forward by various groups within the GEO community, starting with the GEO Expert Advisory Board, EAG, and more recently, the GEO's Infrastructure Development Task Team. They've worked together on a concept architecture that includes the GEO's platform with the emerging GEO Knowledge Hub as a new module of the GEO's infrastructure. The objective of the work underlying the development of this new GEOS infrastructure is well enshrined in the GEO Work Program 2020-2022. That includes the following objectives: to lead the development and implementation of the common infrastructure elements, to provide an infrastructure to facilitate the GEO flagships initiatives and community activities, address the user needs and gaps in terms of data and service, and of course realize the GEO's data sharing and data management principle. Those activities in the GEO Work Program are distributed between various teams. You see them on the slides, the 5 teams: the GEOS Infrastructure Development Task Team that oversees the various activities and components within the foundational task, ensuring the connection and synergies. The GEOS Platform Operation Teams, looking at the daily operation of the GEOS Platform components and their documentation. The GEOS Infrastructure Evolution Working Group, responsible for the GEOS Infrastructure Evolution components. The GEO Netcast, that looks at the daily operation and further development of the GEO Netcast network. And ultimately, led by the GEO Secretariat, the GEO Knowledge Hub, development of the proof of concept and the prototype according to the implementation plan. All this aim at realizing the vision and maximize the benefits that GEO can bring to users through 2025. All around 3 spheres of activity, focusing on advocacy for the value of Earth observation as a fundamental component of timely information, engagement with stakeholder communities to address societal challenge, and delivery of critical data, information, and knowledge to inform decision making. What would the conceptual architecture of the GEOS ecosystem look like? You see, this is more a document under discussion and an architecture organigram with the different components of the GEO ecosystem serving the needs of the GEO flagships and initiatives, the different GEO community portals, and you see the different components and where the knowledge hub in the middle inserts with them as a component of the entire GEOS infrastructure. Let's see now what would be the overarching principle guiding the evolution of the current GEOS infrastructure towards a user-driven GEOS. We have to provide and secure open access to and reuse of the data, information, and knowledge resource developed by or made available to GEO flagships, initiatives, and community activities. We have to offer easy discovery and access to data information resource made available by GEOS data providers, including customization for particular user groups or communities. We have to support knowledge and ensure service meets user needs and expectations, taking advantage of new developments in technologies and standards. What would be then the next steps? We have to continue exploring and developing in a stepwise approach as part of an incremental design and implementation process. And that way we will be able to provide new service and features to the user community. What would be the final recommendation for the synergetic development of both the GEO Knowledge Hub and the GEOS infrastructure? Governing the evolution of the GEOS infrastructure so that it continues to develop in the desired direction. This implies, for example, the need for a stronger collaboration between the current GEOS infrastructure, the GEO regional node, and the GEO flagships and initiatives. Reinforcing the process of formalizing, sharing, and making reusable the knowledge existing in the GEO community so that the GEO principles supporting reproducibility are achieved. And ensuring interoperability with existing and new analytic systems and manage their infrastructure and procedure orchestration. Last but not least, and that would be my final recommendation, we need to ensure that we reinforce interoperability, for example, through the use of open and standard APIs between GEOS and the relevant global system platforms and initiatives such as the UN SDG Knowledge Platform, UN GGIM, UNEP, ECSU, World Data System, the European Open Science Cloud, etc. Thank you for your attention.
Fantastic. So thank you, Jean, for that.
You're
Now
welcome.
we will move on to my colleague, Douglas Kripe, who's a Senior Scientific Advisor in the GEO Secretariat. If you can go ahead, please, Rick.
Hello, I'd like to welcome you to this introductory webinar on the GEO Knowledge Hub. The GEO Knowledge Hub team has put together this first in a series of webinar updates that we are planning to bring to you over the next few months. The objectives of this webinar are to first and foremost introduce the GEO Knowledge Hub to the GEO community so that everyone interested can gain an understanding of the way the Knowledge Hub is shaping up, what its initial look and feel is like, the kinds of information it contains, and the way that that information is organized. Secondly, we'd like to highlight the added value that the Knowledge Hub brings to the community by showcasing a few Earth observation applications that are being developed within the GEO Work Program, and then bringing together the various components of that application into what we are calling a knowledge package. This will facilitate the discovery of the application that has been developed and expand its use. And then lastly, we'd like to convince those who are working on Earth observation applications of the utility and the importance of adopting an open science approach so that they may eventually contribute their knowledge to the Knowledge Hub and thus allow others to adapt and apply the Earth observation-based solution they have developed to other local environments. So the outline of this webinar is going to be as follows. We have a few presentations that we're going to show you. First of all, we'll start with this introduction to the GEO Knowledge Hub. Then we'll focus in on a few of the knowledge packages that are featured currently within the Knowledge Hub. We'll take a look at a few examples of those. Then we'll cover how to become a knowledge provider. This will all be followed by a live question and answer session in which you may pose your questions and answers to the moderator, and then the teams on hand will be available to respond to you. So the starting point for the GEO Knowledge Hub is the recognition that in order for an application to be taken up and used by the community needs to be able to learn about it and to reproduce that application. And all of this being done in an open science context will certainly facilitate the uptake and reproduction of that particular application. And when we talk about open science, we're referring to an umbrella term that comprises a set of practices that encourage sharing scientific findings by making all stages of the research process accessible and reusable. More specifically, the U.S. National Science Foundation Subcommittee on Replicability in Science defines reproducibility as the ability of a researcher to duplicate the results of a prior study using the same materials as were used by the original investigator. That is, a second researcher might use the same raw data to build the same analysis files and implement the same statistical analysis in an attempt to yield the same results. So in other words, reproducibility is a minimum necessary condition for a finding to be believable and informative. However, when we look across the landscape in terms of research, we find that reproducibility is far from a common practice. A survey that was conducted by Nature Science magazine in 2016 showed that there are, in actual fact, irreproducible experiments across all domains of science. This chart here shows the results of that survey, in which we can see, for example, on the left-hand side, the top bar refers to the domain of chemistry, that over 80% of the experiments and results that were achieved through research within the chemistry domain were found to be non-reproducible or irreproducible. If we go down on that same chart towards the bottom and we look at applications related to Earth and the environment, we see that over 60% of applications that have been developed are deemed to be irreproducible. In other words, the work that was done is either not understood or not clearly defined or not clearly explained and is simply not reproducible. And then we see a similar conclusion here over on the right-hand side in this circle chart, in which 52% of the scientists surveyed said that yes, there is a significant crisis in terms of research being reproducible. And then 38% said that there was a slight crisis. So you have over or roughly about 90% of the research that's been done is deemed to be not reproducible. So this was the starting point for the GEO Knowledge Hub. We wanted to take those applications that are being developed in the work program and find a way to make them reproducible so that they are applicable at a broader scales. So what are some of the reasons why applications featuring Earth observations are irreproducible? There are a number of reasons for this. Namely, there's not enough documentation on how the experiment was conducted or the data generated. The data itself used to generate the original results may be unavailable. The software used to generate those original results is perhaps unavailable. It's difficult to recreate the software environment, the libraries, versions, and so forth used to generate the original results. And then the actual computational steps themselves may not be well explained or easy to find. So the Knowledge Hub aims to provide the information necessary to, in a first instance, reproduce the given application. So once again, reproducibility refers to the ability of a researcher to duplicate the results of a prior study using the same materials and procedures as were used by the original investigator. So that's what we see over here on the left-hand side. In the middle, we move on to something that's known as replicability. And that refers to the ability of a researcher to duplicate the results of a prior study if the same procedures are followed, but new or different data are collected. And then if we look at the right-hand side, we come to the point of generalizability, and that refers to the results of a study in which other contexts or other populations or other data are used from the original one. So this is ultimately the goal of the information that we're packaging within the GEO Knowledge Hub. Again, going to the left-hand side, in a first instance, you want to be able to reproduce, to understand exactly what was done by the original investigator through his or her application. But then, because we are encouraging this information to be provided in an open science context, that information is all open. The data, the algorithms, the methodology, and so forth is open to inspection. And therefore, we can move to the middle stage here, replicability, where the same analysis can be performed, but using different data. And you'll see how this applies later on in some of the examples that we're going to show. And then ultimately, the goal of the GEO Knowledge Hub is to make that application generalizable to anywhere in the world. That's the goal. We may not be able to always reach that target, but nonetheless, if an application that was developed, say for, well, as we'll see, for land classification in Brazil can be then applied to other areas around the globe, then we will have reached the highest goal of the GEO Knowledge Hub, and that is to take that application and make it usable, generalizable to other areas around the world. So now the question is, what will be the source of the Earth observation applications that are featured within the GEO Knowledge Hub? Well, the GEO Work Program, with its flagships, initiatives, and community activities, represents a broad spectrum of scientific and authoritative knowledge that's being developed across the GEO community. And in many of these cases, valuable Earth observation applications and solutions are being put together. However, these solutions featuring Earth observations are at the moment scattered throughout the GEO Work Program and are not necessarily organized into a single repository that would facilitate their discovery and uptake. If we consider, for example, the Global Observation System for Mercury or the GEO Global Agricultural Monitoring flagships, or the land use land cover classification being done by the Brazilian Data Cube, the GEO Human Planet Initiative, we'll note that the work of each of these activities of the GEO Work Program provide Earth observation solutions that could have a wider impact if they were disseminated by means of the GEO Knowledge Hub. If we were to focus in, for example, on the Sen2Agri Earth observation solution for crop monitoring example, we would note that there are several what we would call resource components that comprise this particular Earth observation application. So they range from publications, which describe the methodologies being used from peer-reviewed journals. Then we would note the different types of data that are being used, whether they're remotely sensed or in situ or both in some cases. We would note that a great deal of open source software has been produced that is applicable in this particular solution, as well as the computing environment in which that source was meant to run. We would find that there are outputs in the form of maps or depictions of the particular analysis that was performed, and then there would be a wealth of training material. All of these components comprise kind of the end-to-end information chain for this particular application of Earth observations. And as mentioned earlier, these tend to be scattered now throughout the activity itself, throughout the flagship, and are not necessarily combined into a single package. This is what the GEO Knowledge Hub is aiming to do. The GEO Knowledge Hub, in working with the GEO knowledge providers, are looking to identify and prepare all of these knowledge resources so that they can be organized into a knowledge package and be ready for the end user. Now, let's see the GEO Knowledge Hub in action. So here we have the landing page of the GEO Knowledge Hub. This is the page you would see when you first come to the Knowledge Hub and you're attempting as a user to discover and access a knowledge package and its related resources. This page would also be used by knowledge providers who wish to register and manage knowledge packages that they contribute. And then thirdly, it would also be used for those who wish to organize thematic communities around various GEO Work Program activities. So now let's put ourselves in the shoes of a user and imagine that we're looking for a solution that will allow us to do crop monitoring. So if we do a search on the word crop, we would enter the word crop in the search window up above. We would land on this page with a list of results. And in particular, the first one indicates that it is a knowledge package, and it is called Building a Crop Map over South Africa using Sen2Agri. The other results listed below this particular entry show related resources that may be of interest, such as publication or an in situ data set, and many other things. On the left-hand side, you can see a set of filters that may be applied, such as by keyword, resource type, or file format. So let's assume that we want to know more about the knowledge package itself. So we would click on the first entry, on the package entry, and we would land on this page that provides a brief description of the package along with an introductory video. On the top, you can see who created this knowledge package, and you can see its digital object identifier, which is a unique identifier and allows you to always locate it. An interesting feature towards the bottom is that related resources, which basically complement this package, are available, such as publications, data sets, links to open source repositories in GitHub, and other cloud resources. In this particular instance, the Knowledge Hub team worked with the European Space Agency's Food Security Thematic Exploration Platform, where the Sen2Agri analytics platform was deployed. And this means that it is now running successfully on their thematic exploration platform, which allows users to access it quickly without having to download and install it locally on their own machine. Another important feature here will highlight user experiences with Sen2Agri. These are shared through a blog post or a video or any other format that the user would see relevant to show how they used this particular solution, and thus allow new users to get an idea, get a feel for how this particular application has been used, and then determine whether it would fit their purposes. A final feature to take note of are questions and answers. These are questions and answers that will be noted between users who have gone through the package but might still encounter difficulties. For instance, here with the training data set to create the crop map, we would need a place where users can ask questions and have a direct connection with the provider who can help them and guide them through the process. Finally, it will be possible to organize knowledge packages around communities. So here we see, for example, a Geoglam community page that will feature the records we have seen before, user stories, questions and answers, and basically will allow users to have a quick access to relevant resources linked with the work carried out by Geoglam. It will also be the place where active people in the Geoglam community, the knowledge providers, will be able to curate the records and interact with the end users. Now, I'd like to say just a few more words about this concept of open knowledge. As alluded to earlier, one of the strengths of the GEO Knowledge Hub is the fact that the applications featured within the Knowledge Hub will have been developed in an open science context. And this open science context is what leads to full accessibility to the work being done and thereby increases knowledge. By open science, we actually are talking about a variety of aspects of the research process. So for example, we touch on open access, that everyone should be able to access and reuse scientific publications fully, immediately after publication, free of charge and without restrictions. We're also thinking about open data, the fact that the data needed to reproduce the results reported in scientific publications should be released publicly under an open license. We're also referencing open software, that any kind of software that is developed during the research process should be released under an open license. We're referencing open reproducible research, in that the programming code or workflow needed to reproduce the analysis underlying the results, for example, figures, tables, and numbers, in scientific publications should be released under an open license. And finally, open education, whereby the teaching material should be released under an open license, allowing reuse and modification by others. In other words, the overarching goal is to make open science the new norm across disciplines and to create a scientific landscape that will allow everyone to verify, understand, and adopt new research results. Openness in science and education can help address the local, regional, and global needs of society by creating an inclusive and interconnected environment. And finally, an open environment provides equal opportunities and chances for all to gain scientific literacy and benefit from new knowledge and innovation. GEO strongly encourages practices that comply with open science principles to increase the impact of the GEO Work Program and shorten the time from discovery to application. There is a wealth of economic and intellectual advantages associated with this shift towards open knowledge. For example, greater access to scientific inputs and outputs can increase scientific efficiency and productivity through reducing duplication, allowing research from the same data, and multiplying opportunities. Open access to scientific outputs allow for greater evaluation and scrutiny by the scientific community, which means more accurate replication and validation of research results. Indeed, openness to data is one of the main contributions to science's self-correction principle. Then there are economic benefits. Science plays a key role in today's knowledge economies, and increased access to research results, including data, can have a positive impact not only on scientific systems, but also innovation. Global benefits would include promotion of collaboration and faster knowledge transfer for a better understanding of global challenges and so-called wicked problems. And then finally, public disclosure and engagement are enhanced when publicly funded projects are made accessible to promote greater awareness among citizens and promote public trust and support for public policies and investment in research. Indeed, open science also promotes citizen science in experiments and data collection. In terms of innovation, open science can reduce delays in the reuse of scientific research, including articles and data, and promote a swifter path from research to innovation to produce new products and services. And perhaps nowhere has this been demonstrated more vividly than in the current pandemic with COVID-19 and the development of vaccines. Finally, the GEO Knowledge Hub will ensure sustainability and reproducibility of short-term funded projects. So, how do you become a knowledge provider? The GEO Knowledge Hub team is ready to work in close collaboration with GEO Work Program activities to register their Earth observation solutions and knowledge into the GEO Knowledge Hub. The steps required to do so are quite simple. First, we would identify the Earth observation solution that is to be shared. Then you would contact the GEO Knowledge Hub team to start collaboration in identifying the various essential knowledge resources that comprise your Earth observation solution. Finally, with the help of the GEO Knowledge Hub team, you would be invited to co-create the knowledge package based on your knowledge resources to be featured within the Knowledge Hub. So far, the GEO Knowledge Hub team has collaborated with 4 GEO Work Program activities, as mentioned early on, the GEO Human Planet Initiative, Geoglam, the Global Observation System for Mercury, and the Brazilian Data Cube. These 4 initiatives have been pioneers in working and sharing their knowledge and Earth observation solutions with the GEO Knowledge Hub team. And you're going to hear about their experiences in the next 3 presentations. So as a closing thought, the GEO Knowledge Hub represents a collective tool to enhance community intelligence through open science to address societal and environmental challenges. We look forward to working with you to promote your Earth observation applications through the GEO Knowledge Hub in an open science context. And we're very happy to communicate with you at any point along the way. Here is the GEO Knowledge Hub team. Thank you very much for your attention, and I wish you a good webinar.
Fantastic. So thank you, Gilberto, Jean, and Doug. We have a number of questions coming in, and thank you to everyone for using the Q&A function. I'm going to go to one question that was actually answered, but I just want to go through all the questions to make sure that everyone hears the answers. Adrian Guzman, and this is also a reminder to people, Adrian, I recognize your name from CEOS if you're the same Adrian, but if people don't put their organizations, we can't attribute and we can't say who you are. So Adrian Guzman has asked, is it a national initiative or similar to the Open Science Framework? And Doug, you answered, so did you, Gilberto, but maybe I'll hand to you, Doug, if you want to just expand on what you said, please.
Yes, so thanks for the question. If I understand correctly, we're looking for research that subscribes to the general framework of open science, and not necessarily something at the national or local level, but something that you know, if we make reference to I believe it's called the San Francisco Declaration, something that's kind of recognized internationally as defining what open science is. GEO is working on an open science statement, which will probably be coming forth to plenary for a look in a few months. So that would set the framework, at least within GEO, for what we mean by open science. But we're just following kind of the generally accepted framework that's out there now for open science research.
Thank you, Doug. The next question is from Thierry Ronchin, who's from Mines Paris Tech, and is also part of the GEO Program board. He asks, are there any recommendations in terms of license for reuse of software from this work? I'll pass this one to Gilberto Camara, please.
Yes, thank you very much. Thierry, obviously, we would like the licenses to be available for reuse and generalization. If I understand your question right, we would prefer that the licenses abide by one, not necessarily a open source license. There are a number of open source licenses available. I think they are listed in opensource.org. And there is a list that ranges from the very permissive MIT license to the more restricted GPL license. With everything in between, there's the Apache license. So my recommendation, of course, the Secretariat is willing to help whoever wants to share. We can explain, depending on what your interests are in terms of software, whether you want to use a more restrictive or more binding license. So essentially what we want is to make sure that those who want to reproduce and generalize can do so. And that is achieved by adhering to one of the known open source license. So it's opensource.org. I'll check. If it's not that, I'll put a link on the chat. Thank you for the question.
Thank you very much, Gilberto. The next question I see is from Jose Romero, who's from FOEN, the Federal Office for the Environment, and also extensively involved in GEO. Jose has asked about the issue of reproducibility and EO in the context of activities that GEO is interested in. So can I give that one to you, Paula, please? Paula De Salvo from the GEO Secretariat.
Thank you, Stephen. Yes, so if I understand correctly, the question from Jose Romero, we will work with the various entities of the GEO Work Program activities and in the first phase. So to make sure that all the GEO Work Program activities will be included, the knowledge produced by the GEO Work Program activities will be included in the GEO Knowledge Hub. And as we go along, we'll include additional partners. And so for what concern data, this is something that we will look at it in close collaboration with the GEOS platform too. Hope to answer your question.
Thank you, Paula. The next one is from Joan Masso from CREAF. And he says, is this page already open and accessible? Unless someone corrects me, I will say not at the moment. Paula, you're nodding your head. Do you want to answer?
The URL of the GEO Knowledge Hub is a sandbox. It's existing for us internally at the moment. We are working on it and refining a number of functionalities, and it will be made available to the community later this year.
Thank you. Perfect. The next question is from Laurent Durieux from IRD or ERD in France. And he's talking about different processing approaches such as ML, machine learning, and about training sampling data sets being mandatory to tune part of the approach. He's saying that the issue is linked to the sampling approach and also the capacity to get the samples. How is this in situ data issue addressed by the Knowledge Hub? And maybe if Florian, if you're online, Florian, yeah, could you answer that, please?
Yeah, thanks. So there are a few answers to this question. The first one is to clearly state that yes, the Knowledge Hub will be able to store data sets if they're part of an application, for instance, we saw the send to Agri example, then we'll be able to store the training data set used in South Africa to demonstrate the solution. Then if we want to move to replicability, then a key issue is not only the data, but also related metadata to allow others to collect their own samples to reproduce in the setting that they are in the local environment that they want. And finally, we also would like to really work on cloud environments and ready-to-run environment, not necessarily only on cloud, to include in this ready-to-run environment the training samples. I follow quick review and reproducibility.
Thank you very much. So we next have Xiao Yu Feng. How is the Knowledge Hub linked to the existing GEO Catalog? If I understand the question, I think Jean Desart has already addressed that by saying that it's a new module of the GEOS infrastructure and it's linked to the GEOS platform. If that's not your question, please expand your question or provide a more detailed question. The next question again is Adrian Guzman. Are we connecting this to an archival repository? And he's provided an example in GitHub. Can I give this one to Gilberto Queiroz?
So thanks for the question. We haven't discussed about this yet, about this archiving, but behind the GEO Knowledge Hub, what we have right now is really a digital library. So we have already a place to keep all the records and the digital objects there.
Okay. Thank you, Gilberto. The next one is from Lyubka Pashova. What are the differences and similarities between the GEO Knowledge Hub and other global or regional EO science and knowledge hubs? What are the advantages of the GEO Knowledge Hub? Could I give this one to Rick? Rick, are you there? Rick Byans?
Yes, I'm here. I will try to address this question as good as possible. It's one that we get quite a bit. The way I see it, the way I believe the Knowledge Hub has advantages over other digital libraries is the fact that with the Knowledge Hub, we work closely together with the knowledge provider and the GEO community to go this extra step further from having an EO application to sharing that EO application and making sure that the friction of a new user to use that application becomes as slow as possible, as small as possible. And so we will be working very closely with the knowledge providers, initially related to the GEO Work Program, to make sure that documentation is part of the knowledge package. So we're building the knowledge package basically together with the knowledge provider. So, and the big difference is that we're going all the way to the fact that we're providing a working environment. So what we call in software terms a sandbox, where the user will be able to reproduce the EO application, not replicate, but reproduce. So when it comes to replication, then of course the user needs to enter his own data or to connect to his own data. So I see this extra step that where you have only maybe a list that comes out of a digital library. In the Knowledge Hub, we will take the user by the hand to say, hey, here is an environment where you can actually play around with this application.
Thank you, Rick. So I'm going to do a few more questions and then I'll keep some of the other ones till the end. If we can do, I'll take these two from Joanne Massel. The Knowledge Hub is connected to data, but can the data in the GEO portal, the GEOS portal, the GEOS platform, be connected to the knowledge derived from it? And the second one is, if the package has a permanent ID, I'm assuming it should be frozen. how can a package be updated as new knowledge emerges? So the ID issue and the GEOS platform issue, Paula, could you take those, please?
Yes, thank you, Stephen, and thank you, Joan, for these very interesting questions. So to answer the first, let me tell you that we are working in close collaboration. We started working in close collaboration with the GEOS platform team to exactly address your question. Let's take a given user who goes to the GEOS platform and who's looking for data. The direction in which we're working is that the user in the GEOS platform might be prompted with knowledge related to that given data set. And vice versa, if a given user enters into the GEO Knowledge Hub looking for knowledge, it might be prompted with data that are related to the knowledge he's looking for that are residing in the GEOS platform. And as Jean Dussart mentioned this at the very beginning, the GEO Knowledge Hub and the GEOS platform are two essential and complementary components of the bigger GEOS infrastructure. So we're working closely with the GEOS platform team to establish close interoperability at the benefit of the end user, to let the end user benefit at the best from the components, from these two components. And then to answer the second question, yes, a given knowledge package will comprise publication data, a number of knowledge resources as described by Doug Kripe. If any of those components will be updated during the time, the knowledge package will portray a different version, making sure that the previous versions are not lost as well, because we know that historical progress of research is as an important element. And so we will tend to keep the newer version, we will tend to update together with the knowledge provider, because it is important to say that the GEO Knowledge Hub will be successful thanks to the close collaboration of the GEO Knowledge Hub team and the knowledge providers. And so in the case of new versions of knowledge resources, this will be captured in the GEO Knowledge Hub.
Thank you, Paula. If anyone wants to get a further qualification or additional information as part of a response that's already been given, or to embellish or change the question, please feel free to do that. I'm going to move on now to the next part of the webinar, just to make sure we have time at the end for more questions. So this section now is for the examples. And so here we have, again, another of my colleagues based here in Geneva, Ian, who's going to talk, Ian Jarvis, who is the director of the Geoglam Secretariat based here, and he's going to talk about the example with Geoglam in the Knowledge Hub.
I want to thank the organizers for inviting Geoglam to give a presentation on knowledge management, in particular, how we're embracing the GEO Knowledge Hub as a solution to our knowledge management needs. I'm going to give this presentation on behalf of Sophie Bonton from UC Louvain, as well as, of course, Geoglam. So a little bit about Geoglam, who aren't aware of it. We do monitoring at the national to global levels. This includes many EO data and systems, so multiple analytical tools, both Earth observation driven, ag climate, and also bringing in expertise from around the world to vet and develop consensus products. We also underlie this with a very strong research and development activity, the foundation of which is the Joint Experiments for Crop Assessment and Monitoring, or JCAM. And this is a network of up to almost 50 sites now. And this is a global network, produces a lot of peer-reviewed research, but that research is actually oriented towards developing operational solutions that we then turn into the operational systems. And more, we're getting involved in co-development with national agencies, particularly in food insecure, less developed nations. And we found this is a great way, if the countries themselves can implement their own systems, it allows them to develop trusted information that can be quickly turned into decisions, policies, and programs. And when you're talking about emerging droughts or climate emergencies impacting agricultural production, speed is of the essence. So this has proven to be very effective and resulted in significant impact in terms of saving lives, improving livelihoods, and also we found that implementing proactively policies and programs in these countries, they actually save money in the implementation in the end as well, as opposed to responding after the fact. So Geoglam develops monitoring and early warning, as I've pointed out. This provides actionable data and information to decision makers, again, international agencies, national agencies, and so on, and even subnational in some examples. It's underpinned by that global JCAM research network, producing a lot of peer-reviewed knowledge, a significant emphasis on co-development, so there's a growing wealth of training materials and so on to support that. So with all this knowledge being developed, there's a clear need for a solution to organize, access, and manage it. And for that reason, in 2019, we started to partner with the GEO Secretariat to develop a proof of concept using the Sen2Agri on the Knowledge Hub. I'll talk a little bit about Sen2Agri. It's an agricultural monitoring toolbox, if you like, end-to-end solution. So it's underpinned by that peer-reviewed research that helped develop the algorithms that could be applied to agriculture around the world. It also developed the code, which is available openly in GitHub. There's significant training materials online, but also ongoing series of training approximately every 2 months. And more recently, we've been working on cloud implementation so that there's multiple choices for the end user to access the tools in the end. I should also say that this supports the Sen4CAP, which is the Common Agricultural Policy activity, and also Sen4Stats, which is an initiative to work with statistical agencies in these less developed nations to use Earth observations to develop statistically relevant information. And this is all supported by the European Space Agency. Well, the system is quite mature now. It's used in many places. As I showed you in the last slide, there's well over 2,000 downloads globally. The key products it produces right now include surface reflectance, a crop mask, a crop type, and vegetation status, and all this is through the growing season. It's high resolution, 10-meter processing. It can be done for an entire country or a subset. It's seamless processing, and it's accessible through a graphical user interface. So it's relatively easy, but still somewhat a challenge to install and maintain for those who are not that experienced in this high level of activity. Now, it's free and open source, as I said, and it's available under a GPL license. So as we started to work with the GEO Secretariat, one of the things we did was develop an Amazon machine image of the Sen2Agri toolbox. And this allowed us to eliminate a lot of the very technical tasks that are required to implement this in this system in a cloud. We call it click and go, so simply users can go in, use the machine image without having to do all these steps that are seen on the right-hand side. In terms of the Knowledge Hub, a lot of the knowledge resources supporting the Sen2Agri have already been loaded into the Knowledge Hub, and this is just an example of a view of some of them. Here we have the overall package for Sen2Agri. We have publications, we have data sets, and so on. And more importantly, these are all linked with within a knowledge package that brings together all the pieces of knowledge that are required to, in this case, run the Centu-Agri tools for South Africa. Each resource has its own metadata, description, links, and files if necessary. And the user just needs to click on one of these resources and they'll get an infinite amount of information, and it'll direct you to where you can actually access it. And even things like training are available. So this is really the approach that we see working for our community, really lowering the bar and making it much easier for more uptake of the Earth observation technology. As we move forward, our community is currently developing essential agricultural variables. I'm not going to go into any detail about that, but just to say there's many variables that we're developing along the lines of the essential climate variables and so on. What we envision is that eventually we'll be developing knowledge packages to allow the generation of these variables and make it easier for our users to do so. And currently, this is very exciting. We're working on developing knowledge packages specifically tailored for the national adaptation plans for the UNFCCC. Now, these plans are to help less developed nations be able to respond to climate change. We're developing knowledge packages that provide countries easy access to the tools and to be able to run the tools. Central approach to scaling up co-development. So we've already worked and developed operational systems in 6 nations, 1 region. We want to expand that, and there's a big desire for countries to adopt this now. As we move forward, we're going to incorporate things like the Centu-Agri knowledge package that I've already talked about, but other analytical products as well, so that countries have a choice of what they want to adopt. And we're currently developing a set of supplementary guidelines for the UNFCCC NAP process to kind of provide the roadmap, which will end in the Knowledge Hub, which provides that linkage to the knowledge resources. And I should say this work is, at least in part, funded by the Department of Environment, Food and Rural Affairs of the United Kingdom. So that's really all I have to say. I think this is a very important initiative. We're looking forward to the Knowledge Hub being live and being perpetuated. I also see it as a great resource to be able to integrate across our communities, for instance, agriculture, water, energy, and so on, to be able to take information from one community, integrate it with another to create, say, sustainable development goals or other types of integrated analysis that are required to get us where we want to go with respect to our long-term environmental objectives. So with that, I'll stop and thank again the organizers.
Fantastic. Thank you, Ian, and thanks to Sophie for her support as well. I'm going to just remind everyone, if they have any questions about the knowledge providers and what you've just seen presented from Geoglam, please do put it in the Q&A. Our next one is Daniele Ehrlich from the Joint Research Centre of the European Commission. And Daniele is talking in this one about the Human Planet Initiative. If you can put that on for us, please, Rick. Thank you.
My name is Daniele Ehrlich. I work for the European Commission Joint Research Centre. This presentation is about the global human settlement layers. The settlement layers are open source data produced by the GEO Human Planet Initiative and provide information on global built-up, population density, and settlements. This presentation is to inform that the settlements layers and related software and documents can now be accessed online from the GEO Knowledge Hub. A few words on the Human Planet Initiative first. The initiative is coordinated by 2 leading institutions, the Joint Research Center and the Center for International Science Network, hosted by Columbia University. Martino Pesaresi and Dr. Robert Chen are the two co-leads. There are a number of research, policy, and user institutions that are part of this initiative and that are essential to developing the datasets as well as to designing datasets that meet the expectations of the users. The overall aim of the Human Planet Initiative is to fulfill the demand for data on human presence on planet Earth through mapping of settlement patterns and processes. We break this into three objectives. The first objective is mapping human presence globally by sizing the built environment and the population within settlements. The second objective is to help to understand human activities and their impact on the local, regional, and global environment. The third objective is to assess the risks and the impacts of natural hazards on societies. We introduce now the three global human settlement layers. This slide shows the global built-up layer, representing the global built environment. It is available for 4 epochs, 1975, 1990, 2000, and 2015. The built-up layers are produced by processing data from satellite image archives using artificial intelligence. The first product is a binary built-up area map that is then processed into a spatial grid built-up map. The spatial grid records the percentage of built-up within single grid cells. The cells contain continuous built-up area estimates ranging from 0 to 100. By combining the built-up from different epochs, one can visualize the location and size of cities and settlements, as well as the growth of cities and settlements. The image to the right shows the colors red, orange, yellow, and white used to represent respectively the epochs 1975, 1990, 2000, and 2015. That information is of relevance for a number of users, including urban and regional planners, and key to the new urban agenda. This slide shows the population settlement layers that are also available for the epochs 1975, 1990, 2000, and 2015. The population settlement layers are produced by combining census data available at coarse administrative units with finer scale information derived from the built-up settlement layer. Technically speaking, the population settlement layer is also a spatial grid with population counts for each grid cell. One can see the concentration of people in the world with the highest concentration on some large cities. The population density is used in a great variety of applications. It is used operationally in disaster alert systems, emergency response systems, and for example, in the global wildfire information system. The settlement model are generated using the degree of urbanization methodology that was recently endorsed by the UN Statistical Commission as a way to generate standardized urbanization statistics worldwide. The settlement model partitions the built environment into settlement types, such as dense urban areas that typically include cities, semi-dense urban areas that typically include towns and villages, and low-density settlements typically found in rural areas. The settlement model is also available for the epochs 1975, 1990, 2000, and 2015. The unique feature of the settlement models are the spatial boundaries of settlements used to size consistently all urban centers. The settlement model is used, among other things, to implement the new urban agenda and to measure sustainable development indicators. The settlement layers were originally developed to address a shortage of global population and built-up data for operational use in crisis management. Today, the layers are used to generate exposure to hazards and are key data sets in a number of information services. For example, the Copernicus Emergency Mapping Service, the Global Wildfire Information System, and the Global Disaster and Coordination System. The Global Flood Alert System and the Drought Toolkit also use the settlement layers to generate flood and drought alerts. Settlement layers have also been used to assess exposure to hazards in low elevated coastal areas. The three settlement layers are part of the same lineage and are therefore consistent among each other. That consistency has a value in itself, and it is indispensable to compute, for example, the land use efficiency indicator for SDG 11 that requires all three types of information. The settlement layers are also referred to as essential societal variables, as they are used to addressing a number of societal benefit areas. For example, they are used to generate urbanization statistics and used in OECD policy reports. They are used to estimate global emissions broken down at the settlement scale. And the variables feature also in regional studies, including the Arctic, and are considered for use in GeoMountain. The Atlas 2020 provides a short description of over 30 case studies. The datasets can now be accessed also through the GEO Knowledge Hub by typing HPI or GHSL in the search window. The snapshot provides an example and the listing of the GHSL resources you can access. By clicking on dataset, you filter the search only for the datasets. You can also access the software tools that are used to generate the settlement layers. For example, by clicking on tools, you get the population to grid tool that allows to generating the population density grids, the Masada tool that allows to extract built-up information from satellite imagery, and the GHS to degree of urbanization tool used to generate the settlement model. The GHSL knowledge package also lists documents labeled based on the nature of the publication, including scientific publications that describe the science that underpins the datasets, technical notes that summarize the technical characteristics of the datasets, software documentation required to operate the software tools mentioned earlier. This was a short introduction to accessing the GHSL knowledge package from the GEO Knowledge Hub and a short overview of the settlement layers and their use. Thank you for your attention, and we are happy to answer the questions that you may have. You can also forward the question via email to the address on this slide. Thank you again.
So thank you, Daniele. I'm sure you probably had some input from Thomas Kemper and Martino Pesarese as well. So thank you to the team. I just want to remind everyone that you can put your questions in the Q&A for Geoglam or for Human Planet. I'm now going to move to our third speaker, our third knowledge provider for this session, who you've heard earlier on, Gilberto Queiroz from INPE. And he's going to talk about land use, land cover, and the Brazilian data cube. Please go, go, go.
Hello, everyone. I'm Gilberto Queiroz. I work at the Brazilian National Institute for Space Research, INPE. Currently, I am one of the leaders of the Brazil Data Cube project. And on behalf of the Brazil Data Cube team, I will present a case study that demonstrates the generation of land use and land cover maps over the Cerrado biome using Earth observation data cubes, machine learning, and time series analysis. This study case has been prepared in a joint collaboration with the GEO Knowledge Hub team. In this picture, we can see that anthropic activities modify the natural environment, and one way to quantify these changes is through land use and land cover maps. With the help of these maps, it is possible, for example, to estimate greenhouse gas emissions arise from land use and land cover change, identify areas of agriculture expansion, or monitoring deforestation. The application that we are going to show today was developed in the context of the Brazil DataCube project that is part of the technological innovation to improve the environmental monitoring carried out by INPE. We have 4 main goals. The first one is the creation of analysis-ready data from medium resolution images covering the entire Brazilian territory. The second one is to produce what is called multidimensional data cubes based on analysis-ready data. These data products are organized in a way that it is easier to build applications to deal with time series analysis. We also have developed some technologies for big Earth observation data, machine learning, time series analysis. And finally, the project has also a component that deals with the creation of land use and land cover maps using the methods and technologies developed in the project. We are sharing through the GEO Knowledge Hub all the components necessary to reproduce the land use and land cover maps described in our last research paper entitled Earth Observation Data Cubes for Brazil, Requirements, Methodology, and Products. So we structured the data, the code, the computational environment, and the results, along with an extensive documentation on how to reproduce these maps. The application that we are sharing through the GEO Knowledge Hub was developed in a study area located in the west of the Bahia state in Brazil. This area is in the Cerrado biome in an agriculture frontier area. In this study, we collected 922 sample points to train a machine learning model. This was done using high-resolution images by remote sensing experts. These samples correspond to the crop calendar year of 2018 to 2019. The classes collected were crop, natural vegetation, and pasture. This diagram summarizes the method used in our work. We start from the Earth observation data cubes, where we extract the time series of a given pixel. For this application, we used 3 different data cubes with images from CIRRUS-4, Landsat 8, and Sentinel-2. These cubes are monthly composites using a best pixel algorithm. So this produces 12 observations in the year from the whole series available. For each sample point, we extracted the time series, which was used to train a multi-layer perceptrons machine learning model. Once the model is trained, it is possible to classify the entire data cube. So the output of the classifier are the probabilities of a given pixel to belong to each of the 3 classes, crop, natural vegetation, or pasture. And performing this procedure for all pixels in the data cube, we obtain a probability raster. With this probability raster, we applied a spatial model that homogenizes the map areas using Bayesian inference from the information given by the neighborhood of the pixels. Finally, the land use map is obtained by taking the most likely class. The main technology behind the creation of the maps is an open source R package named SITS. The SITS package is designed to work with satellite image time series and to support most steps of the land use and land cover classification workflow, including sample evaluation, machine learning classification, and map post-processing. This package brings together a set of tools for time series analysis and visualization, such as self-organized map clustering and time series filtering. In this picture, we can see how SITS classifies a long time series. It breaks the long time series into smaller ones at periods given by the samples used for training and classifies them using a trained machine learning classification model. The SITS package currently works for Brazil Data Cube and Amazon Web Services environments, and we are developing support for the Open Forest SIPO platform, the Microsoft Azure, and the Digital Earth Africa. So the team prepared this application in the Knowledge Hub, and as soon as the user finds it in the Knowledge Hub, he or she will have access to the knowledge package, to a knowledge package that is the main try point for all the resources linked in the application. The landing page for the application contains a detailed guide about all the resources available and how the user can have access to them. For example, if the user is interested in the sample set used in the research, he or she will have a specific resource with an in-depth description of the set with links to access the samples, the description of its structure, and additional information like a plot of the time series associated to the locations in order to give an idea of the spectrotemporal signature of the set. Another resource that our team has prepared is a sandbox with the computing environment used in the article. This environment is based on the Jupyter technology and contains all the code needed to create the maps. As soon as the user has access to the computing environment with the SITS package already installed, he or she can browse the files and access the set of Jupyter notebooks with the research pipeline. Jupyter notebooks are documents that allow embedding computational narratives that mix code and other results from research through an interactive computational environment. The shared compendium contains a main document with a summary to the other notebooks that explain the computational pipeline to create the maps. So these notebooks contain code and explanation from the time series extraction to the sample point locations, to the preparation of the machine learning model, the classification, post-processing, and validation of the maps. To make the computing environment used in the article available to everyone, we also provide a Docker image with our external dependencies. These Docker images represent a bundle with the entire computing environment needed to run the scripts and to produce the maps. As a concluding remarks, it was a great experience for the team to prepare this knowledge package. We hope to increase the research impact and collaboration network as we share our knowledge in a way that others can quickly learn and try to replicate it for their own needs. The Brazil Data Cube team is constantly improving the methodology behind the creation of the land use and land cover maps, and it is underway the generation of the land use and land cover maps for the whole Cerrado and Amazonia biomes using more classes than the one presented today. All the technologies are available as free and open source software on GitHub. The main technology behind the classification, the CITSAR package, works with data from the Brazil Data Cube or the Amazon Web Services. We are in the road to support SIPO, the Microsoft Azure, and Digital Earth Africa. And the potential users of this application range from environmental public agents, policymakers, and researchers. In the name of the Brazil Data Cube team, I would like to thank the GEO Secretariat for the invitation to participate in this initiative with the GEO Knowledge Hub. Many thanks to all the Brazil Data Cube team for their support on the preparation of this knowledge package. And finally, many thanks for your attention, and I hope we could discuss more about the GEO Knowledge Hub and the Brazil Data Cube applications.
Obrigado, Gilberto. I see Lubia and Karini and some other of your colleagues there, so thank you to Team Brazil. Now, for Ian, Daniele, and Gilberto, I'd like you all to answer this two-part question, and we'll start with you, Ian, since you were the first presenter. Could you just explain your experience, working with the GEO Knowledge Hub, excuse me, and the advantages that you see that the GEO Knowledge Hub brings to your work? So if you could go first on that, Ian, and just let me know if the question's not clear.
Sure, that's great. So there's different aspects to this, but Geoglam is really a coordination activity. We have well over 100 institutions contributing, many projects, and really that's the fuel that runs Geoglam, in-kind funding of projects. These projects usually have defined timelines and defined deliverables. These deliverables are generally knowledge resources. But often when projects end and funding ends, the risk is that we lose the management of that knowledge, and over time it just dwindles away. So the Knowledge Hub allows us to better manage that and maintain it and perpetuate it through time. Second, it allows us to better organize our knowledge resources into packages so we can take from different places, creating packages that meet specific defined needs. And third, GEO is maintaining the infrastructure. We're responsible for the custodianship, so we focus on managing and taking care of our knowledge. We don't need to worry about the infrastructure. That burden is taken away from us. And for one community with not a whole lot of funding, this is very important. And then finally, I would say it's the, and this is yet to be explored, but as we approach things like sustainable development goals and the climate challenges that require integrated analysis across many communities, I think we're going to be able to see the Knowledge Hub as a resource because we're all populating our knowledge packages. Hopefully that will allow us to reach across communities, integrate more of those knowledge pieces into coherent answers to things like specific sustainable development goals and so on. So it really help us build our community over time, I hope. You're muted.
Thank you. I just want to pick up on your last point there about, what we call the GEO engagement priorities around the SDGs and climate action and disaster risk reduction. During your talk, you talked about the knowledge package for the NAPS, the National Adaptation Planning. In the context of GEO and GEO members and the UNFCCC, how does that help your work? Like, what's the impact there? Are you working with the members to do this? Are you working with UNFCCC?
We're just starting to get off the ground on this. We're developing a guidance document that will go into the national adaptation planning processes. But what this will be is essentially a cookbook, if you like. So we're going to use examples from the several countries we already worked with to co-develop their own systems, take from those, and take from the various tools like Send2Agri and others, and put these knowledge packages together that will make it much easier for other less developed nations to come into the NAP process and access the knowledge and do agricultural monitoring, provide new real-time assessments for responding to climate disasters and so on.
Thank you. So Daniele, the same two-part question to you. What's your experience of the GEO Knowledge Hub, and what are the advantages with respect to your work, please?
Yes, thank you, Stephen. Can you hear me? Yeah. Okay. Yeah. So just to want to make sure that I say that I represent the entire Human Planet Initiative. So I have not thanked everybody, but of course also Susan and all the colleagues from all the institutions have contributed to this. So to answer your questions, I would say that I agree with Jan that having our material organized by an outside source with a detached look, I think provides maybe a better opportunity to organize all the material of the knowledge package in a better way. That is certainly one big advantage of the Knowledge Hub. So this independent view of our work. Second is that I agree, we are kind of working on very time constraints, and maybe we are not always keen in maintaining maybe data sets that are maybe old, a little bit old, but that may equally be important in the future. And second and third one is that having all in the GEO Knowledge Hub, I think it will be easier to engage with the other GEO activities, the initiatives or community practices and so on and so on. Because our work is on societal essential variables, so those that are used to address this engagement priority of GEO. So we anticipate that through the Knowledge Hub, it will be easier for us to reach all other GEO activities. I don't know if that helps.
Yeah, no, that's very helpful, and it's very clear as well. So you talk about other GEO activities. In your talk, you talked about the New Urban Agenda, and you talked about SDG 11 for sustainable cities, communities, and settlements. How about not just talking to other GEO activities, but what about that crossing between national government agencies and GEO and the cities who are working more in SDG 11 and the New Urban Agenda? How can the Knowledge Hub help there?
Well, let me say that our data sets are global data sets, and our strength is to be able to provide data that are comparable across the globe. Typically, when we work with governments, we say that you should use the set of data for your country and see how it is useful to you, and let us know if we are be able to help. Occasionally, we do extra processing for some countries. Maybe we do the same processing but using final resolution data, and that happens, and we can provide examples on that.
Great, thank you, Daniele.
You're welcome.
So, Gilberto, you know the questions that are coming, but before you speak, I just want to highlight a comment in the chat from Lubia and congratulate INPE because they're going to have their 60th anniversary this year. And just say thank you to Lubia for that input there in terms of how she thinks the Knowledge Hub is going to help INPE with the dissemination of knowledge and prospects. Lubia, I'll maybe come back to you at the end if we have time, and maybe you can say some more on that intervention. But Gilberto, to you now. So the same two-part question. I presume I don't need to repeat it.
Yes, I have the same opinion as Danielle and Ian. I'm pretty sure that the Knowledge Hub initiative will bring many benefits for the GEO community. This road towards open science, it is very exciting, and it will bring collaborations that we never thought first. So for us, for example, in the case of the Brazil Data Cube, it was very nice to organize the resources in a structured way. And as we developed the resources, we had new ideas, new perspectives on how to prepare something that is really reusable and that we could share with others. So I think that the potential here is infinite here. And please, I would like to ask Lubia also to share his ideas, because I love the way she put the things.
Please, Lubia.
Oh, no, I think that Gilberto is the main person behind this project. What I want to say is that as we do provide data and programs that generate data and official data mainly about the land cover of Brazil, I think that if we have more transparency and we show the role that we are in working with innovation and how we do that, the better our data will be understood and appreciated. And we also can benefit from seeing what other institutions are doing and how they are presenting the work. And so I'm very fond of this project, this initiative. And I think that the idea that the initiative of Gilberto that presenting the results of the Brazil Data Cube is also very, was a very good decision and an important decision, because in this project is where INPE is depositing a lot of its efforts and innovation, thinking about machine learning and artificial intelligence and big data on Earth observations. So I'm very happy to see Gilberto's and Karina's presentation today.
Obrigado. So
Nada.
I think it's interesting because there's obviously a lot of accomplishment around the science and the technology. And Gilberto Queiroz, you said in your talk, one of the things you wanted to do was increase research and collaboration, the network. How are you going to do this in the context of the Knowledge Hub? Do you have an idea?
I think that the way that we are, now I'm talking about with the head of the Knowledge Hub team. So I think that we have a very good plan in the design of the Knowledge Hub around the communities, the organization of the thematic areas. So the way we want the people to share and to participate and engage in the use of the knowledge packages. So I think that when this is finished, this part of the work in the digital library, I think that it will be more easier for everyone to be connected to the specialists, to the experts, to the initiatives.
Great. I think you're correct. I hope you're correct. Thank you. That's really helpful. So I'm going to move back to the general Q&A now and go through some of those questions. There was one from ZXY. I don't know if this is Mr. Heightlat Long or how they're doing it. But the question is there a clear division of labor among the tasks of GEO? Is the whole task theoretical or applied? I think hopefully it's very obvious that it's not theoretical. We've just shown you use cases. Paula talked about the sandbox. We have a lot of work going on, and the knowledge providers are working very closely with the GEO Knowledge Hub team and also then others within the community. So hopefully that has answered that. The next one is from Marcus Conco, who I believe is ITC. Does the Knowledge Hub team provide technical support to create an executable package? Are they also checking whether the code is executable? So my two code friends are Mr. Queiroz and Mr. Bayans. So I think I'll go to Rick, if you wanted to take that.
Yeah, sure. I think in this question, there's a lot of aspects of the co-development of the GEO Knowledge Hub. It's a really important question. And I'm gonna touch on the higher level ones. First of all, the sustainability issue of the GEO Knowledge Hub. Many people have said, well, is the GEO Secretariat gonna do all that work, right? Support all the activities, explain all the technologies, and you have to look upon the GEO Knowledge Hub as a big snowball, and we're trying to push it off a tiny slope. Now, but in the beginning, we will need a lot of push from our side. But once that ball starts rolling, and when it's rolling, that means that when the GEO community picks up on the idea and has that mind shift of putting that extra effort that Lubia and Gilberto Queiroz just explained in their organization, INPE, they just did that extra step. And it brings out such a lot of possibilities. Once we get there, then the technical support will no longer come from us. The technical support will come from the communities. The technical support will come from the capacity development part that we're developing still of that Knowledge Hub. So it's something that if picked up, and it is obviously picked up by the GEO community, these checkings, the executable package and everything will be the provider's responsibility. So that means that on the end of the knowledge provider, there will be some more effort in learning new stuff and doing new stuff. But in the end, the application, whatever the organization is producing, will be so much more powerful and reproducible and replicable. I think that's what I wanted to say on the higher level. I don't know, Gilberto, if you want to comment.
No, I just would like to add that we are aware that there are many technologies that are designed for reproducibility. For example, the initiative from the IFG with the O2R, the CERN initiative with Rihanna, and the Johns Hopkins University with Gigantum. So there are many tools that we can bring and connect in the Knowledge Hub in the future that could also support the providers in this to assure the reproducibility, or at least the executable, the execution of the packages. So thanks.
Thank you, Rick and Gilberto. The next one is from Jiacheng Zhu. How do you organize these data layers and the knowledge? What kind of database is used for storage? Can I give that one to Florian, please?
Yes, sure, thanks. So the Knowledge Hub is built on open source and free technologies. So the database is running with Postgres SQL, and on the organization and the relationship between all the layers. So you have the knowledge package that contains all these resources, but each resource has its own record, and they are linked through digital object identifiers. So that allows a knowledge package to point out to a persistent identifier, such as a DOI, or an external URL if the resource is stored outside the Knowledge Hub, including, for instance, platform, other data repositories, or institutional repositories. This gives flexibility to organize and to list the resources that form a knowledge package, and in the end to allow easier retrieval of resources and not duplicate efforts if the resource is already stored elsewhere.
Okay, thank you. Paula is our multi-part question answerer. So Paula, these are coming to you. Laurent Delieu from IRD again. What is a normal sequence timeline for publishing the data, the tools, this paper, essentially putting the knowledge on the Knowledge Hub? And how easy is it to go through the process of finding what we want to find in the Knowledge Hub? If you can answer that one first, please, or those two parts, please, Paula.
Yes, thank you, Laurent. Well, for sure, the best people to answer this question would have been the knowledge providers, who are the pioneers, the Daniele, Ian, and Gilberto, and the team have been the pioneers, knowledge providers who took part in populating the GEO Knowledge Hub as it stands now. And the normal sequence and timeline and how easy it is. So basically, besides the fact that you as a knowledge provider will know what is the knowledge you want to share, you will be contacting the GEO Knowledge Hub team, and together we will make sure that all the resources related to a given application are interconnected, and we will basically extrapolate all the essential resources that a given user who's not familiar with your application will need to have in order to be able to fully understand and replicate your solution. So it will start from a publication to the data, to the software, to the training. material, and all the essential knowledge resources. Let me give you an example of a timeline. We started to work with the Human Planet Initiative with Daniele and his team. If I'm not mistaken, Daniele, that was November. And by beginning of January, latest, the resources were already inside. And the most time consuming part, which is the most important and delicate part, is the curation and mediation process, because we want to make sure that whatever is in the GEO Knowledge Hub is fully documented and it is of at its best quality for the end user. And of course, you can understand that this part is somehow trying to fill that gap. I think it was Daniele or Ian said before, as we do research, our deadlines are always very tight. And the time we have at the end to secure that the knowledge is fully documented, is stored somewhere, is not enough. And so the GEO Knowledge Hub really aims at organizing this knowledge to be handed in the hand of another end user who will be able to use it. And so this curation process is the time that takes more, is the phase that takes more time. I think that's answer, hopefully, the first question.
I just want to see if Daniele or Ian have anything to add.
Sure, I can add something, Stephen. From a user's perspective, I think the culture around the Knowledge Hub is still evolving. Right now, the tools are being developed. They're not all there yet, so some of the processes aren't as easy as they will be. But so at this point in time, I see the GEO Secretariat doing a lot of the legwork and collecting the information from the knowledge providers and entering it in the system and so on. But as this matures, my vision anyways, hopefully I'm not too far off base, is that all the curation almost all the curation will be in the hands of the knowledge providers, and the tools will be robust enough that we'll be able to access them, create the knowledge resources and link them. And then that will free up a lot of resources for the GeoSec, because they're not going to have to do all those other steps as well. It'll be on the communities to do that. And they can focus on maintaining and constantly improving the infrastructure, meeting growing needs.
Thank you, Ian. Before I go back to Paula, Daniele, did you have anything to add on that?
I would recommend just to the data providers to prepare all the data sets as an open source with all the copyright documents ready, and that the process is relatively easy. With the team, with the GEO Knowledge team was very nice, because once they have incorporated, we just double check their entry, and it was a relatively straightforward process. So it was first, that's what I wanted to mention. And I also wanted to mention that we just started the process. There's so much more that should be available through the GEO Knowledge Hub.
Thank you. That's good advice. That's really helpful, Daniele. Back to you, Paula, if you want to finish off what you were saying.
Yes, probably one element that is important to reiterate is the fact that for all those resources that do not have a DOI, a digital object identifier, the GEO Knowledge Hub is able to associate a new DOI to those resources. And this is a critical feature that, it provides an additional service to the knowledge providers as well, to the end users. And to finish up the second question about how easy it is to find the resources. So, of course, now as we just started to engage with the knowledge providers, the number of resources are not infinite. They will keep growing in the future. But of course, all those resources are associated to the originators, to the knowledge providers, to a given thematic by their type of resources. And as well, something extremely important that we are planning to incorporate in the GEO Knowledge Hub is the functionality that the resources will be organized as well by the engagement priorities, and therefore by SDGs and Sendai and the Paris Agreement. So by having these different classifications, the user will find an easy way to get the knowledge he wants to find.
Okay. Paula, it's very strange that you're only about 50 meters away from me because your network is very crackly. I don't know if you can plug in a network cable or something. So thank you for those. In the last answer from Paula, she mentioned a little bit about curation, but I just want to go to a question from Betsy Hernandez, from our colleague from AmeriGeo and working in the Americas. She said, to ensure materials and data are shared and consistent, will there be a curation process for review? Paula, can I come back to you and maybe just get you to talk through the curation process, just maybe a bit more end to end?
Okay, sure. The curation process, let's take an example of the Send2Agri. The Send2Agri solution, whose final aim is to provide crop monitoring. It had publication, the remote sensing data set, the in-situ data set, the software, the training material, and the output products that was, as an example, for, if I'm not mistaken, Ian, over South Africa. So what we have started the engagement process with the knowledge provider and the curation was making sure that all these elements that are a part, that comprise the Send2Agri Earth observation solution, are fully documented and that are included into what we call the GEO Knowledge package. Because an outsider and a user will need to go through exactly the same research process that the Send2Agri team has done without the time of doing this, but benefiting only of the knowledge that the Send2Agri team has provided. And so it'll be able to read the publication, it'll be able to access the remote sensing data that are essential for him or her to reproduce the solution, and to access the in-situ data or the metadata about the in-situ data that will provide an insight of what type of characteristics he will have to collect on the ground to sustain the software analysis. And then the training material. So this is one part of the curation process. But I would also announce the fact that through the GEO Knowledge Hub, the end user will be able to be connected very quickly to the knowledge providers, asking for their help in case he would need. So he will be, he or she will be connected very quickly to the originator of the knowledge, as well as with other users who have been replicating that specific knowledge package. And therefore, the difficulties that a given user will find on replicating this solution will be shared among the community, and therefore the challenges will be minimized. And so this process of curation and making sure that all the elements are well described it is time consuming, but is, Gilberto Queiroz mentioned it before, it is an exciting process because the knowledge provider and also the GEO Knowledge Hub team, we are able together to go really in depth into the knowledge produced by the knowledge provider and reveal all the hidden parts at the benefit of the end user. I hope it's clear enough.
I think so, and I think as we start to share documentation, people will be able to follow the steps and understand more about what you're saying as well. So thank you, Paula. So I'm going to move on now to our friend Nancy Serby from NASA. And Nancy is very involved in capacity development for CEOS, the Committee on Earth Observation Satellites, as well as GEO. And so Nancy has asked, for new users, what capacity development resources do you provide? And can I give this one to you, Doug, please?
Yeah, thanks, Stephen. So this is a very good question. I think the simplest way to answer it is that there's kind of a two-prong approach, at least right now. The first prong is, as was shown in the introductory presentation, we're asking the knowledge providers as part of their package to provide a video that gives very basic, instruction on how to use the application. So that is hopefully something that will be embedded with every single knowledge package so that it can be self-contained, and there would be other training materials, perhaps documentation that would also be included there. However, we're also thinking in terms of from the Secretariat side of getting in touch with our partners who are in the capacity development line of things, such as ITC, RCMRD, and then our working groups, both in CEOS and in GEO, to find out how we can leverage their networks and maybe work with them to develop training materials, webinars, those kinds of things as we go along. We have now the foundations and the structure of the Knowledge Hub in place, and I think as we go forward, we're going to get a better feel for how we would like to work with our partners in GEO to work on capacity development, because as you've seen, there is a fair degree of technicality to this, and we understand that in a lot of cases it may not be straightforward, even with the materials that are provided. So. And a third thing I'll mention too is that also this idea of the communities that are going to be developed or given a space to occupy within the Knowledge Hub. That would be a third place to go for specific questions related to a knowledge package. So between the knowledge package itself containing either information on its own and the Knowledge Hub containing information within the community, and then working separately with our development partners within GEO, that's kind of the approach that we're taking, at least at this point, with capacity development.
Okay, thank you, Doug. That's very comprehensive. And before you disappear, Doug, there's a final question here from our friend, Mr. Mikko Stralendorf from Finland. If you could just answer his question about what's the link to the GEO Knowledge Hub, or I presume you mean where is it or when's it coming?
Okay, so Mikko would like to kick the tires. We are, since the Knowledge Hub is in a development phase, we're going to keep it under wraps for probably the next month or so. Of course, there is an informational page about the Knowledge Hub that's accessible now, but the actual Knowledge Hub itself, we're going to develop for another month or so, at which point we would like to open up access to the GEOS Infrastructure Development Task Team for them to take a look, as well as the program board. So once we get some feedback from those bodies, say in the up through May, then at that point, I think we're looking at a more general release of the Knowledge Hub.
Fantastic. So just so people know, there was a question about the essential societal variables and how they go, with the ECVs, the EBVs, and all the other essential variables. So Thomas Kemper's answered that and provided a link if you look in the answer section. And again, Joanne was asking about phonology in the Brazil data cube, and Karina has answered that. So I think we are done now with all the questions and answers. So fantastic. Thank you very much, everyone. I now just hand quickly to Gilberto Camara, if you want to say some closing words. Once Gilberto is finished, I'll just let you know that we're going to have another webinar in the series. So Gilberto, if you have a couple of words before we wrap up, please.
Well, thanks you, Stephen, for a great job in moderating. And thanks for the presenters, Daniel, Gilberto, Queiroz, Ian, for doing a very nice job presenting. Doug did a very nice job of setting the scene, and everybody who helped answer the questions. But most it is to the attendees that my thanks are due. Thank you for coming to join us in GEO. And please remember that if you have further questions, the team of the Knowledge Hub is available. If you like to start testing how to publish your knowledge package in the GEO Knowledge Hub and as a test, and to help us and hopefully to help you as well, don't hesitate to contact us, because we would like to really benefit from your experience. Everybody has a different problem to solve and solves in a different way. The more we use Knowledge Hub to disseminate this, how we solve problems in Earth observation, the better for everyone. This has been a fantastic day, and thanks for the attendees for making this possible by your participation and your questions. Back to you, Stephen.
Thank you, Gilberto. So I just want to finish by saying at the beginning, we said this was the inaugural webinar for the webinar series. So we're trying to do them as regularly as possible. So we will be announcing the date for the next one very shortly. And the next one, as you can see here, is going to be a knowledge package deep dive. So we'll be going into more detail and sharing more information about the knowledge packages themselves. So on behalf of the GEO Secretariat and the Knowledge Hub team and all of the knowledge providers, I'd just like to say thank you very much for attending. And you can contact us at secretariat@geosec.org if you need to email or get through to us. Or you can find us on Twitter, Facebook, LinkedIn, you know, we're even on Clubhouse now, and probably nobody knows what that is. But anyway, thanks again for joining, and have a great rest of the day. Thank you.